Hey all, so today we are going to discuss about significance of dimension analysis. So let us start with it. So what is the significance of dimension analysis? So the significance of dimension analysis is basically it can be helpful in deducing the relation between various physical quantities, and it can also be helpful in deducing the verifying certain derivations, and it can also be useful in verifying the dimensional consistency of some mathematical relations. So let us describe it here. The first thing is it can be helpful in deducing the relations between various physical quantities. Like, what is the relation between energy and work and force, acceleration, mass, time, length, etc. So there are various physical quantities, but they are interrelated to each other. So this is one sort of example of how it can be helpful in deducing the relation between various physical quantities, the dimensional analysis. And the second thing is that it can be helpful in verifying derivations. So you have some derivation. Now whether the derivation is correct or not, that can be easily verified at preliminary level, obviously, by using the dimensional analysis. So that's why it is written as it can be helpful. The third thing which it can do, that it can also be useful in checking or verifying certain mathematical relations. Dimensional consistency of certain mathematical relations, right? So dimensional consistency So this is the significance, as we can see, of dimensional analysis. Now we are going to talk about the principle of homogeneity of dimension. So principle of homogeneity of dimensions uh, can be helpful in finding finding the all these significant results. And what is the principle of homogeneity of dimension? So let us talk about it. So principle of homogeneity of dimension, it says that the quantities having the same dimension only can be added or subtracted. The physical quantities having the same dimension only can be added or subtracted. Now this result is very much significant. Now let us understand why it is so significant. If you want to derive a formula or you basically want to, if you have some formula is given and you want to find some of the unknown quantities which are available in the formula, so how you can check it using this relation? So let us take one example, like S equals to A into U plus some B into small a, obviously with some other quantity factor half, which I am including from my side. Now what you want here to calculate what is dimension of A and B using, now so to calculate this, what you will do, you can see that you will use this result which is stated right here, the dimensional principle of homogeneity of dimensions. So it says that two quantities having same dimensions can be added or subtracted, right? So this equation, which is equals to S equals to AU plus half BA, can be further written in a homogeneous equation like S minus AU minus half BA equals to 0. Now this has a one side 0, another with having some variables, another side is 0. So it's a homogeneous equation. Now what does it, now using this result, what we can say, the dimension of S must be equal to dimension of AU must be equal to B dimension of BA, right? Now what is the dimension of S? Now here S is nothing but the distance, right? So this is the one of equations of motion. Out of the three, you know that U equals to you have three equation, V equals to U plus AT, and V square equals to U square plus 2as or minus 2as, depending upon what kind, whether you have acceleration or deceleration. right? And then the third equation is this, s equals to ut plus half at square. So this equation is there. So where s is obviously the distance. Remember that this is purely a distance. We are not talking about any vector. This is all scalar, right? So distance is here. Obviously acceleration is a vector quantity, time is scalar, and if time appears only, and then u is obviously a vector, so just like that. So s is a vector, but here we are talking about the modulus only. So s, so what is its dimension? If it is distance, it is L. It means that AU must have a dimension of L, because you know that there is another rule which says the dimension of two quantities, when they are multiplied or divided, it will be added or subtracted accordingly. So here L is there. Now AU must have dimension of L. So you know that it has a dimension of L t to the power minus 1. So A. So what is the dimension of A? It is simply cancelling out. If you cancel out L, if I say, it gives you A as t. So A has a dimension of time. Similarly, you can calculate B using the same relation between S and BA. Now S is again L, but A has a dimension of L t to the power minus 2. Now just cancel out L or subtract, because subtraction of power. Going to bring it on the other side. So what does it gives you? It gives that the dimension of B is nothing but t square. So you see, using the principle of homogeneity of dimension, you can simply derive the dimension of some unknown quantities in a given relation. So this is the power of dimensional analysis. Please note it down. So let us discuss about another significant property of dimensional analysis. Now dimensional analysis also tells you that if a equation is dimensionally incorrect, then it is definitely incorrect equation. But if it is dimensionally correct, it may be or may not be a correct equation. So what this statement tells you? It tells that dimensional analysis is a first step towards finding the correct equation. So if you want to check whether the equation is correct, it must be first dimensionally correct. Then only it can be moved to means next step to check its consistency. So dimensional consistency is the starting point for any equation to be correct. That one must remember. Now let us write it here. So dimensional consistency is the first step towards checking the consistency of, or towards finding the consistency of an equation. Finding the consistency of a mathematical equation. Sorry, dimensional analysis, you can say, is the first step towards finding the consistency first step towards finding the correctness, basically correctness of a mathematical equation. So a mathematical equation has, if a mathematical equation has to be correct, then it must have to be correct dimensionally first. It means if an equation is dimensionally incorrect, an equation is dimensionally incorrect, then it is definitely incorrect equation. Then it is definitely incorrect equation. And that's why it is recommended for any competitor appearing in any sort of exam, whether you are appearing in NEET, JEE or NEST or any sort of exam at 10+2 level or at higher levels like GATE is there, NET is there, JEST is there, or plenty of exams are there, YTIFR, ISC or like that. So in all the exams, whenever you proceed, when you go for this question papers solving, you first thing you check is dimensional consistency of the equation when you are solving a particular problem. So this is a very much significant thing which or everyone, whether they are physicist or from non-physics background, they are going anywhere in the means dealing in any area of physics, then this result must be in hand. Dimensional consistency, or basically principle of homogeneity of dimension, which is basically a fundamental principle for dimensional analysis of any or finding the dimensional consistency of any of the equation. Now let us check it. So if you have equation, let us take an example to this, understand this thing, right? So like I have a relation K, which is a kinetic energy I am assuming for. It has different relations which are given. K equals to m v cube is the first relation. We have, m square v cube. Then second is K equals to half mv square. Now the third equation is you have K equals to ma. Fourth equation is K equals to 3/16 mv square, and fifth equation is K equals to half mv square plus ma. So you see there are 5 equations. Now what we want to do is that we want to check whether these equations are dimensionally correct or incorrect, which is the first step in verifying the consistency of any of the mathematical relation. So how you can check it? Let us start with the first one. So K is kinetic energy, remember that. Now what is the dimension of kinetic energy? Now any sort of energy, whether it is kinetic, potential or any sort of energy you take, total energy you take thermal energy, you take whatever you take heat, you take enthalpy or any sort of energy you take, in all the cases what you will find that they are different form of energies, so they have same dimension. So this is something one must not confuse. The different form of quantity or different form of same quantity have same dimension. That one must always remember. So what is the dimension it has? The dimension of work is mass multiplied by acceleration. And what is acceleration? That is, mass multiplied by acceleration is force, multiplied by distance is work. So ml square t to the power minus 2 is a simple relation that one must remember. So whenever you are deriving a relation or a dimensional analysis of any quantity, you must remember some relation of that quantity with some known quantities. It will help you in easily deriving the dimension of or formula of any of that quantity. As we saw earlier in our rest of the earlier two lectures where I discussed about the dimensional analysis. So this is their ml square t to the power minus 2. Now this is on the left side. So you take LHS, you take RHS. You simply don't put an equal here. You take a question mark rather than. So what is this? It gives you m square and v is what? Lt to the power minus 1 meter per second. So this L square, which is L cube as v cube is there, and t to the power minus 3. So what do you deduce from here? Are these equations consistent? No. These relations are this relation is not consistent. So this is simply a not consistent relation, giving not because having the same dimension as using the principle of homogeneity of dimension, because if they are, you can change into the homogeneous equation by adding or subtracting on, bringing them on the one side and equating it to 0, so that they are summed or subtracted. In that case, this equation is not consistent. So it means this equation is not at all correct. Remember that. Now you don't need to move further from here or do anything regarding this equation. This is very much sure that it is not correct. Now let us go to the second one. The second one says, again the kinetic energy ml square t to the power minus 2 is there, again the question mark, and this is half, which is a factor. Now dimensional analysis has no role in verifying whether there are factors or what are the means or any scalar quantity. They do not verify them, remember that, and that's why they are not the final step in verifying any of the mathematical result. They are the first steps only. Dimensional analysis is only the first step. So forget about this half. Now check this quantity, which is m, and v is L square t to the power minus 1. So what do you get from here? You see that both dimensions of both quantities is same. It means that this result seems to be correct, or they are at least dimensionally consistent. The correctness is certainly not the forte of dimensional analysis. It just gives you a preliminary idea of whether equation can be correct or incorrect. Right? Now let us go to third one. So this is correct equation, incorrect, correct, and then third one is that k equals to ma. Now if you are smart enough, you can easily find out that this is not correct equation, because m is Lt to the power minus 2 and m is, so the dimensional equation will give you m Lt to the power minus 2, and here it is ml square to the power minus 2. So it means that it is not correct, right? Not equals to ml t to the power minus 2. So this equation is incorrect. So you completely discard these equations which are incorrect. So dimensionally incorrect equations should be completely discarded. They cannot move for the further analysis of their consistency or correctness. Now the fourth equation is that k equals to 3 by 16 mv square. So check this dimensional consistency it has. So what does it gives you? It gives you k, again ml square t to the power minus 2, and this factor which is here, we already said we do not, dimensional analysis has no role in verifying scalar factors. So here m and l square t to the power minus 2. So this equation is correct, right? Dimensionally consistent. I didn't comment anything on the correctness of the equations. So they are dimensionally consistent. So whatever I am talking about in respect to dimensional analysis only, not the complete correctness of equations. So do not confuse it. Now this one, is again now this is ml square t to the power minus 2, but this is what? This is plus ml t to the power minus 2. Now this simply violates the principle of homogeneity of dimension. This violates because two quantities, or even most of them which are correct violates that, most are incorrect which that violates that. So but here it is explicitly visible, in other cases also it is visible. So you can see that these equations which are right here, these relations are not consistent, because this is different. No two quantities having different directions can be added or subtracted. Remember that they can be multiplied or divided, but not added or subtracted. So in future, or maybe in the next class, where I am going to discuss some of the problems, as we are ending this chapter with this lecture. So there I will be giving some interesting examples which were there in some early days of JEE advance, or we can say that JEE mains, which used to happen almost 20 years here, where there were some problems based on the dimensional analysis, and they are really good problems. So, and how you can tackle them using the dimensional analysis. So this is there, which is incorrect or inconsistent. You can write it inconsistent or incorrect. Dimensionally incorrect, inconsistency or inconsistence. Right? So this is one of the main significance of dimensional analysis. What does it gives you? As people usually ask that why do you put so much time on studying something like this, the course topic called dimensional analysis, and this is why we do that. Alright, so please note it down, and if you have any doubt, please do comment in the comment section. Now we will discuss another important property of dimensional analysis. Now let us talk about this is the last topic of this chapter, deducing the relation among physical quantities using dimensional analysis. Now how we can find the relation between various physical quantities using the dimensional analysis, we'll see it by an example. So take an example here. So let us consider there is a oscillator or simple harmonic oscillator is there. So it has a mass of the bob as m length of the thread is as small l, and acceleration due to gravity is obviously which is working there. Is g. So this is all. Now what we want to deduce is that we want to find the formula for oscillation of or time period of oscillator. So let us consider that t is the time period of oscillator, which is directly proportional to m to the power a, l to the power b, and g to the power c. Now let us, which means t is equals to some k, which is a constant obviously, and l to the power b and g to the power c. So k do not have any role here, it is a dimensionless quantity. So t is there. So just compare the dimensions of both sides and find the value of a, b and c. So m to the power a, l t to the power minus 1 to the power b, and l to the power b and l t to the power minus 2, which is acceleration, to the power c. Now just add these powers and compare on both sides. Remember that t has a power 1 because it is. So just compare it with on both sides. So if you compare, you will see that here it is m to the power 0, l to the power 0, and t to the power 1 is there. Here m to the power a is there, l to the power b plus c is there, and t to the power minus 2c is there. Right? Now just compare on both sides to find the relation between a, b and c and their values. So when you equate a is 0, that is the first result, by comparing the power of m, and then comparing a powers of l gives you b plus c as 0, and then the last one comparing the power of t gives you minus 2c equals to 1. What does it mean? C can be reduced as minus of 1 by 2, and then what does the b gives? Using this relation, b gives you 1 by 2. So you found the relation between t, m, l and time period and other physical quantities. So what does it gives you? It gives you, when you put all the powers here, it gives you t is proportional to root l by g. As this is b plus c is 0, so t, what does t gives you? It gives you l to the power half, as l you will put here, it is half, and g which is minus half, and m as 0. So 0, half, minus half. So let me write in that way also. So make it more clear to you. So this is what you are getting. So it gives you t proportional to root l by g. So you can see that we have found a relation for time period of an oscillator or simple harmonic oscillator which depends on root of L by G. So you see, using this property of dimensional analysis, you can simply deduce the relation, simply calculate the formula or basically some simple formula which is obviously preliminary of a given quantity. Please note it down. Here, as I already stated, so this was the last lecture on this chapter 1 of NCERT. Now we will have one more lecture. We will be discussing some of the problems on this this chapter, and which will be from the NCERT also and from some other places also. So please watch these videos and do comment, like and subscribe.